Lesson 94, solving rational inequalities. So I'm just going to start right with an example of a rational inequality. 5 divided by x plus 3 is less than 7. If you can remember that 7 is a fraction as 7 over 1, and then you can just cross multiply and get 5 times 1 is less than 7 times x plus 3. So whatever side the numerator is on, the numerator stays on that side. That way you know what side of the inequality it's on. So the 5 stays here, the 7 stays here. So you multiply up. So you get 5 is less than 7x plus 21. And then I can subtract 21 from both sides. Negative 16 is less than 7x. So negative 16 sevenths is less than x. So case 1, wait a minute. Okay, so x is greater than negative 16 sevenths. But in the denominator, so x cannot be equal to negative 3. So if the denominator is positive, so case 1, if the denominator is positive, then x will need to be greater than negative 3. Okay? Can't equal negative 3, but it could be greater than. Case 2, if the denominator is negative, then x will have to be less than negative 3. So we have to decide if it's greater than negative 3 or less than negative 3. So you can just imagine if x is less than negative 3, this will be a negative number. 5 divided by a negative number will be negative, and it will always be less than 7. True?
Yeah.
Okay, if x is greater than negative 3, you have a positive number. Wait a minute. Oh wait, we know that x is greater than negative 16 sevenths, which is negative 2 and, what's negative 2 and?
Less, it's bigger.
Oh yeah. So it just has to be greater than this number. It won't be any, yeah, it'll overlap. So it's either x is less than negative 3 or x is greater than negative 16 sevenths. It won't go in between those two. Less than negative 3 or greater than that. Now I'm going to teach you what I think is an easier way. And even in the book they say it's an easy way. But I don't know if you'll consider it easier. So if we have a problem like this, x plus 4 divided by a bunch of factors, x minus 3 times x plus 2 times x plus 1. And that is greater than or equal to 0. What you want to do is you want to test values where the numerator and where the denominator equals 0. Okay, so you're going to test values where
Bless you.
the denominator and numerator equal 0. So we're going to use, we want to test values. So we have -4, 3, -2, -1. So we're going to use, for the denominator zeros, we're going to use just greater than or less than. We're not going to use any or equal to. And then with the -4, we're going to use less than or equal to or greater than or equal to. So let's put in a little note here. Use less than or greater than for -3, -2, -1, because they're in the denominator. So here's what our table's going to look like. Boom, boom. And we have to go, we're going to go like this. X plus 4, x minus 3, x plus 2, x plus 1, and then what the value of the expression will be. And it's not going to be a value so much as is it positive or negative. So we're trying to decide if it makes them positive or negative. So we have to go x is less than or equal to -4. And then we have -4 is less than or equal to x is less than the next smallest number, which is -2. Then we want to go between -2 and -1. So -2 is less than x is less than -1. Notice we're not using less than or equal to. And then we go between -1 and 3. So -1 is less than x is less than 3. And then we have to go above 3. So x is greater than 3. So we just look at x plus 4. So if x is less than or equal to -4, we have a negative value, true?
Yeah.
For just this one. If x is between -4 and -2, then we have a positive value here. If it's between -2 and -1, it's positive. If it's between -1 and 3, it's positive, and of course this one will be positive. Okay, so we do that for each of these. So a number less than -4, this will be negative, this will be negative, this will be negative, this will be negative, and this one will be positive. X plus 2, we're going to have negative, negative, and then it's going to be positive from there on out.
No, that's positive.
That is positive. Then x plus 1 will be positive, negative. Nope, that's a negative. This one is not positive because less than or equal to -4 will be negative. Sorry, I got that wrong. So negative, 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 and then positive, positive. Okay. In the denominator, we are multiplying these numbers together. So I like to just kind of, okay, these combined, if I multiply 3 negatives, I'm going to have a negative. If I multiply these 3, I'll have a negative. I'm just multiplying those 3 because that's in the denominator. Okay, those 3 are in the denominator. So a negative times a positive times a negative is a positive. Negative times 2 positives is a negative. 3 positives is positive. Now, value of our expression we want, is it positive or negative? So we're dividing a negative by a negative. This will be a positive. Divide a positive by a negative, negative. Positive divided by a positive, positive divided by a negative, positive divided by a positive.
This is positive.
So we want only where this value is positive, greater than or equal to 0. So we pick x is less than or equal to -4, or it's between -2 and -1, or greater than 3. So this will tell us, well, it's greater than or equal to 0 in these values. Okay, there's a couple of ways, or just one way, to do it on a graphing calculator. Yes?
I'm really confused on how you got all those positive, negatives, and like.
I'm just imagining if I plugged in a number less than -4, this value will be negative.
Okay.
Okay?
Oh, okay. I get what you're saying.
If I plug in a number between -4 and -2, this is going to go positive.
Okay, that makes a whole lot more sense.
Okay. So I'm going to show you how you can do this on a graphing calculator, which might make it a little bit easier if it's not greater than or equal to 0 like it was on that previous one.
Yeah.
So here's an example. X over x plus 8 is greater than or equal to -1. So this is a graphing calculator example. So in your first y equals, put in x divided by x plus 8. Make sure you put that in parentheses. And the second one, put y equals -1. Okay, what you want to look at on your graphing calculator, so real quick, let's just draw a picture so you can see what I'm talking about. And I don't have it.
That's pretty fancy.
Yeah, that's not. I hurt my cheek. Okay, so, I mean my lips. X divided by x plus 8 and -1. So I'm just going to do a zoom standard on this one, just to see if that works. Okay, I'm going to zoom out so I can see what it looks like over here in this upper corner.
Whoa.
Okay, so it's up here. It's up here. So we find where they intersect, which is at when y equals -1. So it's -4, -1. So we want to look, we want to use -4 and -8 for our two values that we're going to check, -4 and -8. So when I look on my graphing calculator, oh, I need to zoom. Okay, wait, I have an idea. I'm going
Wait,
to,
it can't be -8. This is very good.
it can't?
Yeah, because then it'd be on.
Oh, I know, that's why we're using that value, because we're checking in between. You know, like below this one, in between those two, and above that one. We got to check those regions to see. So wait, I'm zooming back in so we can see it.
Regions of the graph.
Because of
Like greater than or equal to.
right here, they intersect right at whatever we said, -4, -1. Okay, so that's a critical value is what they call it. So you look at, let me think about this for a minute. Where it's above the lines, where it's positive because it says it's greater than or equal to. So where is the graph greater than or equal to? So when x is greater than or equal to -4, this graph is above or equal to that line.
So what's the point of the -8?
Yeah, I don't know what is that point. Oh, because that's where this is right here. That's your asymptote where it won't cross.
Okay.
So you would say x is greater than or equal to -4. And then if you look here, x is less than -8. The graph is above the line x equals -1. But it can't be equal to because it will never touch. So x has to be less than -8. So you're just trying to see where it's positive. So x is less than -8. So on here, you're just looking at where is the function greater than or equal to -1. If this said where is it less than or equal to -1, you would say, well, it's between -8 is less than x, or it's less than or equal to -4. So -8 is less than x, which is less than or equal to -4. That's only if it said less than. So you look at this to see what part of the graph you're looking at. Okay, I have one more example that's a word problem. I should read the word problem too, so we know I did not want to write it. Okay, a group of students are sharing the cost of a $60 gift card for their teacher. So nice. Write and solve an inequality to show the number of students whose participation would bring the cost per student to less than $350. So you're buying a $60 gift card and you want each student to pay less than $3.50, okay? So the inequality would be $60 divided by each student needs to be less than $3.50. So I would go to the graphing calculator. I would graph 60 over x and the $3.50 or 3.5 and find that they intersect at 18 and 3.5.
It's about 20 people.
The denominator is 0 at x equals 0, so x cannot equal 0. That's the asymptote. So you look at where the graph is less than, which is at 18 people. So x can be greater than or equal to 18 people. So at 18, it would be less than $3.50, or it would be equal to $3.50.
You just find it and then round up.
No, it's or more. If you do more, then they're going to each pay less amount per. Wait, that's the end of the lesson, so we can answer.